Hey everyone, here we are, 6.2. More confidence intervals for the mean. The only difference in this section is that right here, the population standard deviation is unknown. In 6.1, we are always given that population standard deviation sigma. In this section, we don't have it, which maybe is more logical, right? Why would you know the population standard deviation when you don't know the population mean? So this section maybe is more frequently used. What we have to use, though, in this case, is a different distribution. It's called the t distribution. Okay, so there's lots of information here you can read through about the t distribution, but the key is when you use it, we'll be using that sample standard deviation S, right, instead of the population standard deviation sigma. Okay. Now, some interesting things about the t distribution. There's a formula. Notice there's just pretty much the same comparison, right? But you're just using S instead of sigma, T instead of Z. Okay. Now, the t-score does depend on the sample size. So that's the strength of this distribution. Whereas the normal distribution, the sample size never mattered. But in the t-distribution, the sample size affects the curve. Okay, so you'll see this term called degrees of freedom. It's the statistical term, but it's a pretty simple formula. We're just going to do n-1 for that. Okay. And here's just some different graphs of different degrees of freedom. So notice the curve changes depending on the degrees of freedom, which is based off of the sample size. Right. Now, the StatCrunch does have a t calculator, so we'll be using that. Otherwise, a lot of it is going to be similar to 6.1. Okay. There's just some more properties, some similar properties of the normal distribution, but just gives a little bit more accurate data because we're including that sample size. Okay. Some differences. T-distribution has more spread. Okay. Things like that, fatter tails. So the first thing we'll need to do is find critical T values instead of critical Z's. Right? So that's called the TC. We could use a table, but online class I like to focus on the StatCrunch since we'll always have that available to us. So let's practice with finding a TC for a 90% confidence level, sample size 15. So you will need the DF. So if the sample size is 15, the DF is 15 minus 1, 14. Let's jump to StatCrunch and see if we can find it. So, sorry, I got to get back to my home page. Okay, so we're going to just open StatCrunch. Got a main page here. Same location as we've been going, stat. All right, now we're going to go under calculators, a very first choice. And there's a new spot, right? If you look down, you'll see a choice T, or capital T. We're going to choose on capital T, and there's our T calculator. All right, if you look at what is involved, notice the first thing we got to put in is that DF. Right? So in this problem that we're working on, it's 14. So I put in 14. And then same way we were doing it in the normal distribution. Sorry, I got to click between. Because again, it's going to be between two values. Right? So there's the setup. Put in the DF 14, click between, and then I don't know why that big old percentage is there. We'll remove that, and then that's where we put in the confidence level. So this one was 0.9, 90%. Right, so I'll put in 0.9 and then compute, and I get my critical T score. Again, all we need is the positive one, so 1.761 is the critical value. Okay, so use this calculator anytime you need a critical value, and you should be good. And the notation for it is TC. So I'm going to write this down as T sub C, and that's 1.761 approximately. That's really the main difference in this section, is getting a t instead of a z. Because look at that formula, it's really the same thing, it's just t instead of z, right? S instead of sigma. This is exactly the same, right? So the process of these problems we've already done. So let's put it all together and do an example. You randomly select 16 coffee shops. N is 16. So DF is 15, right? And I can just jump to that right off the bat. Sample mean, X bar, 162. Sample standard deviation, S, is 10.0. You can just write 10. C, 0.95. And away we go. So first thing is we need the TC. Right? So what is the TC? That's when I got to jump to StatCrunch. Right? So we don't have any little tables like in the first one. You just got to always use StatCrunch on these. So I just head back to StatCrunch real quick, and I can punch it in. Right? So the DF we figured out was 15. And our confidence level was 95%, right? Right. Okay, and then compute that, and we get 2.131. Right, 3 decimal places should suffice. If you want to be a little more careful, you can go 1314, but I'll just go with 2.131 for my TC. Right, 2.131, there we go. Okay, and then here we go, margin of error. 2.131, the TC, right, following that formula above there, right, times the S, which is 10, divided by square root of N, 16, right? So don't put the DF there, go back, for the full N of 16, and calculate that with your calculator, and I'm getting 5.33 when I punch that in, okay? And then what do? Same as before, we add and subtract to the sample mean, right? We'll take the 162 minus the 5.33 and the 162 plus the 5.33. Calculate those, round to the appropriate spot, and we get 156.7 and 167.3, and there's our confidence interval, okay? So what's the main difference? It's that t, right? Finding that critical value is different using StatCrunch with the T calculator. Okay, so hopefully that's looking pretty good, and we'll keep on going here. So as we go to the next page, you're gonna have to figure out, okay, which distribution should we use, Z or T, right? When they start mixing these problems together, it just all depends on one thing, the standard deviation. If you know the population standard deviation, you're using Z, right? So population is Z. If you know the sample standard deviation, it's T. Okay, that's it. Nothing else matters. So on these problems, another little thing is you do have to verify that this is true. Okay, either the population itself is normally distributed or the sample size is at least 30. Okay, so if both n is less than 30 and the population is not normally distributed, you can't really even do the test. All right, so one of those has got to be true. So all of your problems, they'll probably be true. Okay, so let's try one. Let's see, do we want Z or T here? So if you're trying to find Z or T, go to your standard deviation, and if it's population, like in this case, that's Z. All right, so this problem is just a 6.1 problem. So we can review that now. All right, we can run through that. 95% confidence. You start memorizing these. It's 1.96, right? And then the E, remember how you do it? You go 1.96 to ZC times the standard deviation, using that little formula, 28,000 divided by square root of N, 25. And there it is. And I think this works out to exactly 10,976, which is interesting. Okay. And then what we're going to do is take that, here's another way to write it, taking that sample mean, adding and subtracting I'm doing it this way because these numbers are so long. I don't want to write them all out, right? I can add and subtract that value, right? And so boop, 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 punch into my calculator, and I get these two dollar amounts, 170,024 and 191,976. Okay, we got that. All right, so there's a little bonus problem from 6.1. Okay, and you'll see that in 6.2. They'll try to throw you some Z's just to make sure you're paying attention, I think. Okay, how about number 3? Okay, so again, I'm looking for standard deviation. There it is. Whoops. Erased it. Standard deviation. It's a sample standard deviation. T, automatic. I only have to read the rest of the problem. I just know it's T based off of that. Okay, so then that's like the one we did before. We need a TC, right? So the TC is based off of the 90% confident, right? And it's a DF of 7, right? If the sample size is 8, DF is 7 right there. So I can go to StatCrunch real quick. And we're putting in DF7. Level of confidence 0.9. Compute. And I get 1. Let's say 895. Okay. We got it. Okay, so I'll go back here. 1.895. Away we go. Getting used to this formula, right? So the E is going to be always that critical value first, times the standard deviation, divided by a square root of n. Calculating that, I'm getting 4.82. Okay. What do I do with that? Add and subtract to the one number we haven't used, right? That mean number of minutes. Right. So I'm going to take 35.5, add and subtract 4.82 for my final answer. 30.7, 40.3. Okay. And don't lose sight of the interpretation of these. We are 90% confident that the population mean, right, we're still capturing the population mean is between 30.7 minutes and 40.3 minutes. All right. Oh, raw data. Okay. We got some raw data again. We know how to tackle that. And this one, it has some parts, right? Find the sample mean, the sample standard deviation. Parts A and B, we've done before way back in chapter 2, right? So we might have to pull some chapter 2 here on this problem and then construct the confidence interval. Okay, so first step, let's load the data. Okay, back to StatCrunch. We want a blank page, right? So starting fresh. How are we going to do this problem? Well, let's go to my groups because that's where I'm going to have the data. There it is, 6.2 college student GPA. So load data, step 1. Now what I'm going to do, before I even do a confidence interval, I'm going to do some summary stats. Right? So this is the chapter 2 stuff. Remember we did this summary stats, that second choice of a column. I select my column, it's under var 1. Right? And then I just hit compute. I don't think I need to put anything else in there. Okay, and what that gives me is my mean, my sample mean, and my standard deviation, right? So the X bar and the S. So the mean is 2.35, standard deviation 1.03. Okay, so I can write that down. So sample mean 2.35, that's from part A. Part B, 1.03. So you're going to have to use that summary stats to get those. Okay. Now let's do the confidence interval. So I can go back to StatCrunch. Let's close that out. Oops, I still have my GPA. So I got my data loaded again. Right. I don't know the population standard deviation, so this is a T distribution. So what do I do now? I'm going to go to stat. Now the new location. Notice before we were going Z-stat in 6.1. 6.2 is T-stat right below it. See where it says T-stat? I'm going to click on that. And it's one sample. And with data, because I have the raw data. I select the column. I choose confident. This one was a 99% confidence. So 99% confidence. Hey, why not get the critical value? And I compute. Okay. And that'll give me my confidence interval. Also, you get the sample mean again here. So you will get the sample mean. What you don't get is the standard deviation. You got to go to that summary stats for the standard deviation, the S. But we get the critical value, which is cool. And we also get that final answer, 1.6 to 3.1 for the confidence interval. Okay. So part C, 1.6 to 3.1. And there she goes. All right, whatever that means. Okay, so we did it. And that's the end of this section. So I'm going to stop there. Give 6.2 a try. See how it goes. If you have any questions, let me know. Otherwise, I will see you in 6.3. Talk to you later.